Hi, my name is Seth Williams. I am currently a student at Oklahoma State University Institute of Technology, and this is a video that is going to go over point-to-point protocol and kind of give you an introduction of what this process is and everything that you kind of need to know to get started in understanding it. First, we will go over what is point-to-point protocol. Point-to-point protocol, it provides a standard method of transporting multiple programs and datagrams from point-to-point links such as routers, making them communicate in certain layers. Point-to-point protocol is comprised of different components that we'll go over in just a minute, but the important parts to understand is that it's used to encapsulate layer 3 protocols for transmission across different serial links. Again, being able to make routers communicate and transfer information effectively, as well as an open standard that helps support authentication, error detection, the quality of monitoring, and load balancing between these networks. So going over the different components, there's three main components, the point-to-point protocol. The first is really the second point that I have on here, which is link control protocol, because that's what does the main work for all the PPP. What it mainly does is it helps establish, configure, and test the data link connections, and it does, like I said, a majority of the authentication as well. The next portion is a method for encapsulating the multi-protocol datagrams. That's basically just sending the information from one side to the other. And then finally is a network control protocol, which is establishing and configuring different layer networks of protocols. So if it starts with a layer 2 and eventually moves to a layer 3 for information transfer, this is where the NCP will come into effect. Kind of making sure I don't miss anything on this as we discuss it. Just some of the other points we need to kind of make up is let's try and find out what the difference between point-to-point and peer-to-peer is. So point-to-point is a protocol for communication between two computers using some kind of serial interface. A good example of this is VoIP, okay, so voice over IP or phone. That's a good way of communication. The old school networks before Cisco kind of took over was the old dial tone that you would hear on internet dial-ups. That was generally trying to communicate and establish some kind of, at that time I think it was a TCP, or not TCP, NCP at the time, well before what we were doing here. And eventually when they made it to where you don't have to do the dial-up anymore, it became more of a point-to-point protocol instead, to where it moved to a faster communication method. Peer-to-peer is a communication method model which has one party being able to open the communication on both sides, not just sending or creating a communication from one end to the other. So a good example of this is BitTorrent. If you ever use BitTorrent, someone can download from you as you are communicating with them. And so it's a two-way communication that's open on both sides and can be communicated back and forth. So those are the difference between point-to-point and peer-to-point, or peer-to-peer. Are there requirements? Yeah, there's all types of requirements when it comes to point-to-point protocols. Okay, the first one is packet framing. Packet framing from network layer is basically what begins and ends the frame for each segment. You also have transparency, which is a network layer packet. It's got all the headers or your data layers for it. Then you've also got multiple network layer protocols. These are able to support multiple network layers while running over the same physical link simultaneously. And then you also have multiple types of links that are requirements. Okay, this is what you need to operate a wide variety of link types, such as parallel or synchronous. It can do low or high speed as well, and even do electrical and optical syncs. Finally, you have to have some kind of error detection, being able to detect bit errors that are received by the frame. That's something we'll go over once we do the model. And then you have connection liveness. This is something that detects a failure at the link side, and then eventually moves into a signal error condition on the network layer. Okay, then we also have the network layer address negotiation. This is a mechanism used for communicating network layers and learning to configure each other's network on layer addresses. And then finally is simplicity. The first and foremost among all these requirements is the simplicity. It's the point-to-point protocol should always be simple. It should be effective and simple. Okay. So what are some of the non-requirements? You have design non-requirements that you have to have as well. One of these is it needs to be required to detect bit errors, but it's not required to correct those errors. So even though it's an error detection, it's not exactly an error correction. The next part is a flow control. It doesn't really need to have flow control, it just receives frames in the full rate. That is not just an underlying or physical rate. So there's no need to control any of the higher layers. So layer 3 doesn't have to control 4 or 5 as well. It needs to be able to just do the ones underneath it. Sequencing is not required. It can deliver the frames in the same order as it's received. And then finally, multi-point links is only on the single sender and not the single receiver. So multi-point is just being able to do multiple simultaneously. So what does this model look like? Well, first and foremost, the model kind of looks like this. Okay, each section is kind of broken down for a PPP format, and it begins with the simple stuff. So first we start off with the flag. This tells the router where to begin or end the protocol frame process. What it does there is it will then move into the next section, which I actually messed up on that. It's supposed to say protocol, but it's actually the second section that says flag. That's actually the protocol section. And this states which layer 3 protocol is encapsulated within the actual data field. So once you're going from the flag to the actual protocol piece, then you move into the packet. And I'll show you the error I have right here. This right here should be protocol, and it is not, so I will change that. Okay, and then moving into the data field is where we kind of have what we're looking at. So the data field is where the IP packet is the main portion, I guess you could say, and it has changed through time. So the original HDLC didn't have this data field basically, and then later on it would Cisco introduced this type of field, so that way the PPP that way when the data type field could tell what type of IP packet it was, so it could communicate more effectively. And then later on the PPP introduced this data type field as well. Finally, the PPP will end with a frame check sequence. This is used to detect any of the errors that we talked about earlier. So when information comes across in bits through the address and control section, later on it will then check to make sure that those are correct, and that frame check sequence will then not kick back any errors, but it will tell you what the error codes really are, and then it starts back over with another flag. So again, going back through it, the flag is what tells you where it begins and ends. The address is not always used in PPP, so it can but it can also support the address. Okay, back in the HDLC broadcast times, this used to be your broadcast addressing. Then you have your control portion, which is not necessarily part of the PPP, but it helps with the sequencing and connection. And then you have your protocol portion, which is the upper layer protocol that frames the delivery and tells you which layer you're going to use. And then when you have your data section, this is the upper layer being carried for information. And then afterwards you go into your frequency check. So those are the portions of the PPP format and the protocol itself. So to kind of summarize this, PPP operates at layer 2 of the OSI model. That's something that we just kind of have to understand, but it can go into a higher section, okay, and it's made for layer 3. PPP, as we discussed, is made up of 2 main components, even though there's a third one. The 2 main components are the LCP and the NCP. So the link control protocol does most of the heavy lifting, does the link establishment, the authentication, configuration, data link connection, and stuff like that. And then the NCP, which is the network control protocol, which is what configures different layer network protocols and then establishes them as well. And then the third part that I really didn't leave on there is the minor part, which is the encapsulation of the multi-protocol datagram. At the end of this, we just kind of need to remember that each of the layer 3 protocols still has a layer 2 underneath it. As we talked before, it doesn't really affect the upper protocols, or the upper layers, but it does affect the lower layers, because if you have a layer 1 underneath a layer 2, then you have a layer 2 underneath a layer 3. But it doesn't have to do anything higher than that. So hopefully this gets me where I need to be, and helps you guys kind of understand a little bit about the PPP process, even though I'm kind of new at it myself.